let's look at weak acid, weak base, strong acid, and strong base solutions. Here I've prepared 5 solutions, one of them just plain water, and I've put a little indicator in it so it has a slightly yellow color. But let's look at some HCl, strong acid, acetic acid, a weak acid, ammonia, weak base, and sodium hydroxide, strong base, all at about 0.1 molar concentration. So the pH is about 1. That is, if the strong acid HCl is in 0.1 molar concentration, completely dissociates, makes 0.1 molar H3O+. Minus log of 0.1 is 1. The HAC, weak acid, dissociates to a lesser extent. So the pH is higher, indicating a lower concentration of H3O+. Water, concentrations of H3O+s at around 10 to the minus 7. NH3, now we're getting to a base, so the H3O+ concentration drops even further. So I get a higher pH, 10 to the 10, and a NaOH, 10 to the minus 13 H3O+ concentration, but 10 to the minus 1 OH minus concentration. The OH minus and the H3O+ concentrations, the product is always 10 to the minus 14 in water. So I can look at these and we can put a little indicator in each, and as we put a little indicator in, we'll see the color reflective of the relative pH. There's my strong acid solution. Here's my weak acid solution. Let's add a little more so that we get a little darker color. Here's my strong acid solution. Here's my weak acid solution. I already added a little indicator to the water, so we'll skip over that one. And my weak base solution. So the base turns this indicator blue. That's a nice little mnemonic to remember because the bases are blue, both starting with the same letter. And here's sodium hydroxide, the stronger base. Solution. So that's indicator in the strong acid, weak acid, water, weak base, and strong base solution. Now, the number of ions in each of these solutions is indicative of the acid and base strength as well. HCl, remember, completely dissociates. So 0.1 molar HCl makes 0.1 molar H plus ions and 0.1 molar Cl minus ions. So I have 0.2 molar total ion concentration. And that ion concentration will make the solution conductive. So if I test the conductivity, just kind of qualitatively with this light bulb, I'll see that HCl, there's ions in there. Ions conduct, and I'll have a strongly conductive solution. If you look at the, by comparison, water, very low concentration of ions, 10 to the minus 7 H3O+s, this non-conductive. And in general, water, pure, is not a conductive solution. So let's look at the weak acid. Now the weak acid dissociates much less strongly than the strong acid. So the HAC does not completely break down. So I'll have a lower concentration of ions in the weak acid and a lower concentration of ions at dimmer light. We should see the same correlation between the weak base and the strong base. The strong base should give us bright light, and the weak base should give us a dimmer light, fewer ions in solution. So what we notice is both the indicator and the ionic strength, the strength of the conductivity of the solution, strong for the strong acid, slightly weaker for the weak acid, essentially no light for the water case, and a weak base, ion concentration low, strong base, ion concentration high. A correlation between pH, color, and ionic strength for acid and base solutions.